All right, so good morning, good morning. Hope everybody's doing well, everybody's doing all right. So we'll go ahead and get started, get rolling. Last class, we knocked out 10-1. So today we'll look at 10-2. And starting off with triangles. It says the angles of triangles add up to 180 degrees. So if you have a triangle, then that will always be the case. The angles in your triangle will add up to 180. All right. So first example says find the measure of angle A for the triangle ABC. So they give us in the figure, they give us B and C. They want us to find the measure of angle A. And since we have a triangle, we know that A, B, and C will add up to give you 180 degrees. And so always try to hold on to that because the statement has already been made and there's no guarantee that they're going to mention it or give you a hint from this point forward that the angles in the triangle add up to 180 degrees. If they tell you it's a triangle or they have a shape that is in the shape of a triangle, they assume you know all three angles will add up to 180. So we can go ahead and add up 120 and 17. Hold on one second. Let me check something real quick. I just wanted to make sure my stuff was set properly. Okay, so that's 137. Then subtract 137 from both sides. And that'll be 43 degrees for angle A. Or if you just wanted to subtract 120 and 17 from 180, that still would give you 43. It just depends on if you want to set up an equation or not. Some of this stuff. So here they give us this diagram and tell us that the measure for angle C is 40 degrees, measure for angle E is 60 degrees, find the measure of angle D. So it tells us to find the measure of angle D, but in order to do that, we're going to have to find A and B as well. So we just need to find all the angles. All right. So once again, they give us angle C, which is 40 degrees, and angle E, which is 60 degrees. The easiest angle to find first is angle A. This is a vertical angle with angle E. So angle A is 60 degrees. And then we have a triangle here. So that means A, B, and C add up to 180 degrees. So that's what I did here. Just minus 60 and 40 from 180. You got 80 for angle B. And then looking at B and D, we have a straight line. That means we have a straight angle, and that's supposed to add up to 180 degrees. And so that's how I find angle B, or angle D, excuse me. I subtract the angle B from 180. All right. Questions on that? Scrolling up. All right, next thing, we're looking at triangles and their characteristics. So first classification is by angles. And we talked about angles last class, being acute, right, obtuse, and so on. So an acute triangle has all angles inside the triangle acute. A right triangle, one angle is 90 degrees. Third one, an obtuse triangle, one angle is obtuse. If I scroll up too far. Next set, classifying the triangles by sides. Isosceles triangle, two sides have equal length. Angles opposite these sides have the same measure. Like holding on to obtuse. Okay, so these little slashes here just let us know what's equal. So we have our two sides that are equal, and then two angles that are opposite those sides are equal as well. All right, equilateral triangle, all sides have equal length. And if all sides have equal length, remember we only have 180 degrees that we can play with as far as the angles inside of our triangle. So if all sides have equal length, all measures have equal length, and that means all measures of your angles will be equal to 60 degrees. The last one, scaling triangle. Equilateral. No two sides are equal in length. No two angles are equal in measure. All right, is everybody done with this? What's the next page? Very good. All right. So still dealing with triangles. Now we're getting to similar triangles. Similar objects have the same shape, but not necessarily the same size. All right, so properties, the ratio of corresponding sides are equal. The ratio of corresponding heights is equal to the ratio of corresponding sides. And the measure of corresponding angles are equal. So we'll put some numbers on that in a second. All right. So just to emphasize those relationships, we have two similar triangles here. And I set up my ratio, small side over large side. So if I look at the bottom size, AB, place that over DE, that reduces down to 1/3. Try to color code it a little bit. BC, that right side, and EF reduces down to 1/3, and then also AC and DF reduces down to 1/3. So it's showing you how the corresponding angles, corresponding sides, excuse me, will create equal ratios. All right, let's scroll up. All right, so we have triangles ABC and DEF are similar. Find FG. Just write that down. All right, so notice we have the bottom side is 8 and 12, 8 for the small, 12 for the large. And then we have the height is set up for 4 for the small. FG is what we're trying to find for the large, so I call that X. I'm going to set my proportion as small side over large side or big. And so it's up to you how you want to set it up. A couple different ways you can set it up. You just have to be consistent across your proportion. So like I said, I'm doing small over large, because you're large over small. It's up to you how you want to set it up. But if I'm going to do that, then I would do 8 over 12, which is AB over DE. And then for my height for my triangles, 4 over X. Once you have your proportions set up properly, go ahead and cross multiply. Always take your denominators up to your opposite numerators. So that'd be 8x on the left, 12 times 4 on the right. Then to solve for x, we can divide both sides by 4, and x is equal to 6. Questions? Any questions? Let's scroll up. We're doing the last problem. So another 2 statements about similar triangles, something to help you establish whether you have similar triangles or not. Is if if the three angles in one triangle are equal in measure to the three in another triangle, then the triangles are similar. And then this next statement says, if two angles of one triangle are equal in measure to two of another, then the triangles are similar. That's because if you know two, then since you only have 180 degrees to play with, you can figure out the third one as well. And that third one is going to be the same if the two are the same in the other triangle. I can scroll up. All right, so I'm going to erase some of the stuff from this diagram. Well, so we have a figure, and in this figure, angles B and D are right angles. And we have side AB is equal to 12, DC is equal to 4, and AC is equal to 18. Find the length of CO. Well, just giving you the diagram the way you may get it, and then I'll go ahead and put my symbols in according to what's given in a second. Give you guys a chance to write. All right, so putting all my symbols back in. Notice the first statement in the directions. They tell us that B and D are right angles. So I'll put the square back in there. And then they tell us the size A, B, and DC, 4 and 12. And then give us AC is equal to 18 meters. And so if you look at this line of AC, notice O is in the middle. So that means AC is equal to AO plus OC. And so we're trying to find a CO. OC and CO are the same thing. So now if I wanted to break that up into two pieces, and I don't know what either piece are actually. So I know that this long side, whoa. Let's see if I can put that back. One more time. It's not. All right. So that long side of AC is 18 altogether. If ever I have a total number and I want to break it up into two pieces, I can always do this right here. Call one X and then the other one the total minus X. So if I had 20 and I want to break it up into two pieces, I can call one X and the other one 20 minus X. If I have 100, call one X and the other one 100 minus X. I can always break it up that way. And it doesn't matter which piece I call which, when I go about doing my solving, I'll still get my same numbers. So that's why I call this X and then the other piece 18 minus X. And then I label them as such here. All right. So also recognize that when I look at my 90 degrees, that's here. Then also both of these angles, because I have vertical angles, are equal. And then in that last statement that we just finished talking about up here, if we know two angles, then we know the other one as well. And that means that these are equal. And so that's where I got that information from. Once again, it gave us 90 degrees. These are vertical angles. So that means they're equal. So that means this one is equal as well. So since all three of my angles are equal, that means I have similar triangles. And that means I can do this right here. My ratio is going to be the same. All right, so that's why that's important to establish. All right. So now I need to match up my sides, corresponding sides, CD and AB correspond. So that's why I put that CD over AB right here. And then CO and AO. And that's why I have this right here. And once again, setting up my proportion is small over big, small triangle sides over the larger triangle sides. So it'd be 4 over 12 equal to X over 18 minus X. Cross multiply. 4 times 18 minus X equal to 12X. Distribute 4. 72 minus 4X. Add 4X to both sides. $72 equals 16X. And then we can finish it off by dividing both sides by 16. All right, questions on that before we go to the next one? All right, anybody holding on to this? All right, so we just finished talking about similar triangles. Similar triangles, once again, is when you have the same shape, but the size may not necessarily be the same. Congruent triangles, means they have the same shape and the same size. So we have three different theorems that will help us establish whether we have congruent triangles or not. The first one is side, side, side. I use THM for short as far as theorem is concerned. So side, 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 if three sides of one triangle are equal to the corresponding three sides of another, and the two triangles are congruent. Next one, side angle side. If the two sides and the included angle of one triangle are equal to that of a second triangle, the two triangles are congruent. So once again, two sides and their included triangle is a generic representation of that. And the third one, angle side angle. The purple one. If two angles and the included side of one triangle are equal to that of another, the two triangles are congruent. All right, all right, so we could ask you, are the two triangles congruent? Remember, in order to establish congruency, it has to fall in line with one of those three theorems. So here we have two triangles and we know the angles of the two triangles, all three angles, and those all three angles are equal. They're 45 degrees, 55 degrees, and 80 degrees. So the question is, are they congruent? And from this given information, these triangles are not necessarily congruent. So we need more information. Remember, I gave you three different theorems: side, 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 angle, side, angle. And this is angle, angle, angle. So we don't have one based on your angles. Now, if you know all of your angles, that establishes that they are similar. Remember, that's what we use to determine that they're similar, but we need more information in order to determine if they are congruent. Use one side. All right. And the next one, of both triangles, we see that two sides are equal, 16 and 18, and then in between both of those sides, we have 60 degrees. So these triangles are congruent. They satisfy side, angle, side. All right. Anybody holding on to this before we scroll up? All right, last thing out of this section, Pythagorean theorem. Holding on to it. All right. So Pythagorean theorem, it's only used for right triangles. And it's a squared plus b squared equals c squared. A and b are interchangeable. C has to be on one side by itself. So oftentimes it's reference to A and B are legs. C is always your hypotenuse. C is always opposite. 90-degree angle is always your longest side, and that always has to be on one side of the equation alone. All right, so dealing with your Pythagorean theorem, normally they ask you to find the missing side. So here we have 5, 12, and the missing side here. And notice once again, C is always opposite to 90 degrees, the right angle. That's always the longest side. Let's pull it up. All right, so you just plug in the values and then solve for the one you're looking for. So in this case, we know A and B, trying to find C. So that would be 5 squared plus 12 squared equals C squared. 5 squared is 25, that's 5 times 5. 12 squared is 144, 12 times 12. All right, that gives us 169 equal to c squared. Now you want to solve for c, not c squared, so you take the square root of both sides, and then c equals 13. Any questions? Any questions? Everybody good? Everybody straight? Let's see if I can make that. All right, so we're good to go. That's it for 10.2. Any questions? Everybody good? Everybody straight? Okay. So next class we'll get into 10.3 and go from there. All right. So you guys are good. I'm good. Have a good day. Be safe, and I'll see you next class.